So sometimes I'm really bad about telling you what page you're writing on, because if you don't have something to print this off, obviously you're going to need to write in your notebook. You're on page 32. I say that, let me check. Yep, 32. And this is frozen, so give me a second and we're going to unfreeze it. There we go. All right, number 32, page 32 is 4.2. Let me check. We should be filling out our tab and always forget to. Constructing arithmetic sequences. That's also the title for 33, and we will do both 32 and 33 today. Okay, so you have or are going to write on 32 with this fold. We don't have to copy it all down, just some of it. This one's not printed right. Let me go grab the other one. Give me a second. I'll be right back. Okay, this one is. I'll throw that one away. Okay, so you have a foldable that looks something like this. Zoom out some more. Put my notebook to the side. Looks like this. I'm going to fold it in half. Okay, I'm actually going to glue. See where this line right here is? I'm going to glue down that line. You can't really see it. And I'll glue with purple so you see what I'm talking about. And then I'm going to fold it on that line right there where I glued it. It's going to look like this. And I'm going to cut on the dashed lines after I've glued it together. All right, we're going to talk about arithmetic sequences. Arithmetic sequences is kind of a segue into linear functions because a line can be shown in an arithmetic sequence, and you're going to see what I'm talking about in just a second. So let's talk about what is an arithmetic sequence first. An arithmetic sequence is a sequence of numbers such that the difference between the consecutive terms is constant, meaning to get from negative 12 to negative 5, you are going to add 7. To get from negative 5 to 2, you're going to add 7. To get from 2 to 9, you're going to add 7. Now notice theirs goes backwards. Here's what they're actually doing. To find the number, they did the second minus the first, so minus a negative 12. That's what they actually did to get that 7. Okay, so we're actually going to talk about how to find the difference. To find the common difference, which is normally written as D, you subtract the first term from the second term. The difference between any two consecutive is constant. So we do 22 minus 32. Take this first and subtract it from the second. That is negative 10. So you should have minus 10, minus 10, minus 10. That seems to work out. So you write D equals negative 10 when it tells you to find the common difference. D stands for common difference. D for difference, of course, not common. It is common difference, but if it doesn't have a common difference, it's not arithmetic. All right, let's open up and talk about how to find the nth term with an explicit formula. You're actually going to need some highlighters, and I didn't get any out. Okay, how to write an nth term explicit formula. I want you to highlight the word explicit in blue. You need to know the difference between an explicit formula and a recursive formula. Go ahead and highlight explicit and recursive everywhere you see it on this front here. We've got explicit, explicit, recursive, recursive. We need to know the difference. Yesterday we talked about the difference. We said explicit is where you literally just plug in. Recursive is where you have to know the one before it, okay? All right, so to write an nth term explicit arithmetic sequence, this formula will always be given to you on tests. It's on that formula sheet we glued in the back of your notebook. It says the explicit rule for the nth term of an arithmetic sequence is a sub n, like a submarine, that's why it's below, equals a sub 1 plus parentheses n minus 1 times d, where a sub 1 is the first term and d is the common difference. We are going to take highlighters and highlight the pieces of this formula that we change. We only ever change a sub 1, which is the first term, and d, which is the difference. The rest of this formula will stay exactly how it is. You're going to see what I mean in 1 minute. Let's look here. We're going to go ahead and list a sub 1. A sub 1 is the first term. In this example, the first term is 25. Now, we need to list the difference, the common difference. Basically, we take 30, subtract 25, and we get 5. From here to here is 5. So is from here to here. And from here to here. We don't have to find it for all of them if it tells us it's an arithmetic sequence. So D equals 5. Okay? Those are the pieces I have to pick out. Now, what I'm going to do is I'm going to take this formula that is always given to you, so you don't have to memorize it. I ripped my paper. And I'm going to plug in a sub 1 and d. A sub n, I'm going to leave it alone. It's like f of n from yesterday. Equals a sub 1. Instead of a sub 1, I'm going to put 25. Okay? Plus n minus 1 times d is 5. Now, I'm not finished with this. I need to simplify it. To simplify, I'm going to bring down 25, and I'm going to distribute. 5 times n is 5n. 5 times negative 1 is negative 5. Last part, a sub n equals. 5n does not have a like term, so I'm going to write it down. 25 minus 5 is 20. Here is my formula. That is what my answer would be, 5n plus 20. So explicit is the only one that you're going to simplify. All right, let's keep talking about explicit. It says how to find the 10th term using an explicit formula. To find the 10th term of a sequence, substitute the value of n into the explicit formula. Well, we're looking for the 10th term, so the value of n is 10. So a of 10, or sub 10, equals 2 times 10 minus 5. You can either plug that in directly or do it in your head. 2 times 10 is 20. 20 minus 5 is 15. So a sub 10 equals 15. That is what I was looking for. So there's the explicit rule. In the explicit rule, you are going to plug some stuff in to find the term. You're going to simplify the formula. Now let's talk about recursive. I'm going to close all these so we don't get too confused there. We're going to get to the last piece down here, which is the recursive formula. Okay, recursive. Remember yesterday, recursive means we use the one before. In recursive, just like in explicit, we only change two things. The recursive rule for the nth term of an arithmetic sequence is a sub 1 equals a sub 1. You replace the second a sub 1, not the first. And then we put a comma. We don't. We're going to skip a line. A sub n equals a sub n minus 1. Remember yesterday when we had f of n minus 1 and that meant the one before? Well, that's what that means. Plus d. D is the difference. Just like before, a sub 1 and d mean the same thing. Okay, we're going to identify them and write the recursive rule. You do not have to simplify a recursive formula. You can't simplify it. Okay, let's go ahead and identify a sub 1, which is 10, and then the difference. The difference is 6 minus 10, which is negative 4. These are the two pieces I need to plug in this formula. This is the formula. But instead of a comma, I'm going to put it in a separate line because I don't like that. All right, so a sub 1 equals 10. That's the first part with the comma. Instead of a comma, though, I'm going to skip a line because it looks neater. Then a sub n equals a sub n minus 1. And it says plus d, but we have a minus here, so we're going to put minus 4. This is the recursive rule. I cannot simplify it. This says that it starts with 10, and then after 10 you subtract 4. That's what the recursive rule is saying. Okay, so let's do the example of finding a term. It says use the recursive formula to find the first 4 terms of the arithmetic sequence. Well, that's what I did yesterday. I'm going to have to find 4 terms. In the recursive rules, I always have to make a table because I have to use the one right after it. So it says the first 4. So number 1, number 2, number 3, and number 4. We already know the first one is negative 3. Then the rule says, right here, it says we add 5 to the one before it. So negative 3 plus 5 is 2. Then add 5 again, 7. Add 5 again, 12. There's how I find the terms in a recursive rule. In explicit, I plug it in recursive, I have to use the one before. We're going to go ahead and glue this in on page 32, or you wrote on 32. If you wrote on 32, make sure you wrote the formula down. If you didn't, go back, find the formula, write it down. You're going to need it. Okay, we're going to then go on to 33. So if you're just writing in your notebook, it's on page 33. If you're not writing in your notebook, you've got this in front of you, you're folding this in half. Okay. So we're going to keep going. We're going to talk about whether these are arithmetic or not. Remember, in order to be arithmetic, they have to have the same difference. And here's how we decide. We're going to do 2 minus negative 1. 2 minus negative 1. 2 minus negative 1 is 3. So you added 3 to get from here to there. Okay, well then negative 3 minus 2 is negative 5. Notice these are not the same. This is no, not arithmetic. That's all I'm doing. Yes or no? No, that's not arithmetic. All right, let's look at this one. 12 minus 14. We went down by 2. Subtract 2. Okay, is this subtract 2? Yep. Is this? Yeah. So, yes, this is arithmetic. Good. You do have quiz questions like this. All right, 3 to 6. Looks like we added 3. 6 to 9. Added 3. 9 to 27. Ooh, I think that's 18. I better check. 19. Yeah, 18. That is not arithmetic. That's why you have to check them all. You don't have to check them if it says, hey, this is already arithmetic. That's only if it says, is it or not. Okay, let's open this up. Let's keep working. We're using the formulas that are on the last one. Okay, so when you're like, where is she even getting this? They are the formulas that are on the sheet just a second ago. I'll pull them back out so you can see them. Let's go ahead and actually write them at the top so you know what I'm talking about. The explicit rule was A sub n equals A sub 1 plus n minus 1 times d. Sometimes you see the d in front of that. It just depends. The recursive was A sub 1 equals A sub 1. And then it had a comma, but we didn't like that, so we skipped it. I said we, like you had a choice in that. Plus D. So write those at the top. You're going to need them. All right. The instructions say write a recursive rule and an explicit rule. We have to do both, okay? We are going to go ahead and find the first term and the difference for all of these, and we're going to do it up here because that's not the answer. The answer are going to be these two. The first term, here is the position number. That means the first term is 2,000. The difference is 2,500 minus 2,000, which is 500. We are going to use these and plug them in. We're going to start with the explicit rule just because I wrote that first. A sub n equals, the first term is 2,000 plus n minus 1 times 500. Remember, the explicit rule you have to simplify. You don't have to simplify the recursive. So A sub n equals 2,000 plus 500 times n is 500n. 500 times negative 1 is negative 500. Now, combining like terms, A sub n equals 500n doesn't have a like term, but 2,000 minus 5,000 is 1,500. There is my explicit rule. I'm going to put a big E here. I'm not going to write explicit because I sure don't want to. I like to write as little as possible. I'm going to draw a line right here so I know that I'm doing the next part, the recursive part. I want you to organize your homework in some way so I can tell the difference. Yes, I know what the answer should look like, but I just want you to be able to know. I need to know that you identify the difference. All right, so A sub 1 equals 2,000. Yes, you have to write it again. A sub n equals A sub n minus 1 plus 500. Here's explicit, here's recursive. I'm going to put a box around recursive, a box around explicit. We have done both. That's all I have to do on that problem. I want you to pause the video and try number 5 on your own. I'll move it so you can see the rule, but you should have written them down yourself. Alright, the first thing we do is identify the first term and the difference on all of them. The first term is 155. The difference is 141 minus 155. I believe it's negative 14. Yes. Okay. I'm going to need a calculator. Sometimes I make simple math mistakes. I know that one's right, but when I distribute in a second, I'm probably going to want it to add. Okay. Let's go ahead and start with the explicit. A sub n equals 155 plus n minus 1 times negative 14. Okay. A sub n equals 155. Distribute. Negative 14 times n is negative 14n. Negative 14 times 1 is positive 14. A sub n equals negative 14n. And then 155 plus 14. Excuse me. That is 169. Here's the explicit. Now we'll do recursive. A sub 1 equals 155. A sub n equals a sub n minus 1 minus 14. There's both. Okay, number 6. These they do take a little bit of time, but it's not a lot of math involved. It's just a lot of plugging in the formula. Okay, these are written differently. They're not in a table, but all that's missing is the position number, but you should know that. This is the first, this is the second, this is the third, this is the fourth, okay? We just don't have the position number anymore. We're going to go ahead and write a sub 1 up here and d right here, so we got room down here to do the rest of it, because this isn't the answer, remember? We just need it to plug in. The first term is 100. 88 minus 100 is negative 12. Okay, so we're going to start with explicit. A sub n equals 100 plus n minus 1 times negative 12. Distribute. A sub n equals 100 minus 12n plus 12. A sub n equals negative 12n plus 112. There's the explicit. Divide your paper somehow. Here's the recursive. A sub 1 equals 100. A sub n equals a sub n minus 1 minus 12. Make sure you have both answers on your homework. All right, pause the video and try number 7. You only learn math by doing, so if you're not pausing them, remember you can ask help. I have Google Meets if you need them. All right, the first term is 0. The difference is 8, because 8 minus 0 is 8. A sub n equals 0 plus n minus 1 times 8. A sub n equals 0 plus 8n minus 8. A sub n equals 8n minus 8, because 0 minus 8 is negative 8. Okay, recursive. A sub 1 equals 0. A sub n equals a sub n minus 1 plus 8. Okay, last but not least, so we've seen them in a table. We've seen them when it's just a string of numbers. Now we're going to do the exact same thing. We're still doing the same thing, but when it's in a graph. Okay? So it says Jerry collects hats. The total number of hats in Jerry's collection depends on how many years he's been collecting hats. After the first year, Jerry has 10 hats. Each year he has added the same number of hats to his collection. The graph shows this sequence. Okay? The first term, a sub 1, is whatever 1 is. It's 1 comma 10. The first value is the position number. So it's 1, and then the first term is 10. So 1, or the x, is the position value. The difference. How did we get from 10 to 18? Or what is 18 minus 10? And that is 8. That's the difference. That's what's changing every year, okay? Now that we have those, just like a second ago, explicit, recursive. Okay, I'm going to draw a little line here so we separate them. Explicit, we will have to simplify. A sub n equals the first term plus n minus 1 times 8. We'll distribute. 8 times n is 8n. 8 times negative 1 is negative 8. 8n equals 8n. Doesn't even look like an 8 very well. 10 minus 8 is 2. Here we go. We're going to learn about linear functions starting next week. This is a linear function. We could draw a line straight through there. Okay, recursive. A sub 1 equals 10. A sub n equals A sub n minus 1 plus 8. That's all I had to do. That's all it asked me to do. The instructions are the same. I want you guys to try number 9. So pause the video, try it out. Okay, you've paused it. I hope you figured it out. Start by writing A sub 1 and D. The first term is 1 comma and 6 is the first. How do we get from 6 to 9? Well, it looks like we added 3, so it's positive 3, or 9 minus 6. Explicit. A sub n equals 6 plus n minus 1 times 3. That's something that, like I told you, the explicit is given to you, but it's something you really quickly start to remember as many problems as we're doing. So you distribute them, because you have to simplify explicit. You have 3n, and then 6 minus 3 is plus 3. Okay, we're separating the recursive and explicit so we know the difference between them. Recursive is A sub 1 equals 6, and A sub n equals A sub n minus 1 plus 3. Okay, so that's it. We're going to glue that in your notebook. You're going to work on the assignment today. This goes on page 33 of your notebook. You should have already labeled it, but if you didn't, here's the label. You should be filling in your tab. I have not been filling in my tab. And I will right now. So there we go. Oh, I'm going to go fill in my tab. Your homework is in the book tonight, not a worksheet like yesterday. So I'm going to go back and fill in my tab that I forgot to fill in. Dimensional analysis was 22 and 23. Graphing was 24, 25. Understanding was 26, 27. Modeling was 28, 29. Identifying was 30 and 31. And today's was 32 and 33. And tomorrow's will be, I'm going to go and fill it out because you know how much I forget. Tomorrow's is 34, 35. Okay, so I'll see you tomorrow. We'll do 4.3 tomorrow. Go ahead and work on your homework.